First, I'll begin by showing you our chromatography paper and us filling the cuvettes with the solution. Then, we started scanning for absorbance.
We scanned our samples across all wavelengths to determine the best wavelength for measurement. Scanning across all wavelengths helps identify the maximum absorbance, called the lambda max, where the sample absorbs the most light.
For example, scanning ensures we are not missing peaks at unexpected wavelengths, and it allows us to compare two samples that might have similar absorbances at other wavelengths but different lambda max values.
Lambda max is defined as the wavelength at which a compound has its highest absorbance. Using this wavelength ensures our absorbance measurements are accurate and reliable.
By scanning all wavelengths, we can also compare absorbance values, quantitative, and the shape of the absorbance curve, qualitative data, to fully analyze our samples.
When light passes through a solution and we want to determine its concentration from how much light is absorbed, we need to use something called the Beer-Lambert law.
The Beer-Lambert law is expressed as the absorbance equals the molar absorbativity multiplied by the path length of the cuvette in centimeters multiplied by the concentration of the solution.
Absorbance is directly proportional to concentration. If we fail to zero the spectrophotometer using a blank, our absorbance values would be higher than they should be, leading to an inaccurate concentration calculations.
The molar absorptivity is a constant specific to the compound. The path length is measured using the cuvette, and concentration is what we are calculating from the absorbance.
This ensures we can relate absorbance to the actual concentration and verify the accuracy of our measurements.
Here you will see some pretty interesting shots of us cleaning our workspace, of course, cleaning everything we use. Here's our lab notebook and our worksheet. In our notebook, all samples are labeled clearly. We recorded absorbance data for all samples. Data and calculations correspond to the volumes shown previously in the video. We wanted to make sure our notebook is easy to follow for anyone wanting to review the experiment later.